Okay, well, I want you to be aware that this lesson is a direct continuation of Endocrine15a. The file just got too big and too messy, so now we're going to talk about the hormones that come into the ovary and then other hormones that are made by the ovary. Okay, now we're ready to talk about a lot of the hormones, and I'm going to bring down my visuals, of course. And this is a very critical, incredible diagram. Now we've already talked about follicles and follicular walls and inside the follicle and outside the follicle. I'm going to draw a line here that indicates the basement membrane of a follicle. And I can bring that up here. And so you can say my black line is the follicular wall. Okay, so let me do this. Outside of the follicular wall, you can see I'm making little dots. And those are theca cells. Theca cells. There should be a plural on that, an S on that. And then inside the follicular wall, I'm making blue spots, and those are granulosa cells with an S. Granulosa cells. So now we can explain this. LH from the anterior pituitary. Go to that lesson if you need a review, and the next few minutes I'll spell that out for you. Anyway, LH, a protein hormone from the anterior pituitary, comes in the blood. One of its target tissues is the theca cells. Those cells take cholesterol. Remember, cholesterol is the precursor for all steroid synthesis. And they make androgen. That's a family name, but the most famous family member is testosterone. Okay, so then testosterone is made by theca cells, and it diffuses across to the granulosa cells. And the granulosa cells take testosterone, here depicted as androgen, and change it into estrogen by the enzyme aromatase. That's a general name for an enzyme. So I'm going to say the granulosa cell produces estradiol 17 beta. That's the most famous estrogen, naturally speaking. Now, granulosa cells also make a protein hormone called Inhibin, and I slid that over there. And the next diagram we're going to be exposed to is really going to show you how complicated this is. But the bottom line for this is theca cells out here, see my red laser pointer, make testosterone. It diffuses across the follicular wall, which is a basement membrane. Then the granulosa cells, depicted in blue here, convert androgen, or we'll say testosterone, to estradiol 17 beta. Now the other thing is, which is kind of neat, is that there are blood vessels out here. Notice where I'm drawing them. I'm drawing blood vessels outside the follicle. So some of the estradiol 17 beta produced inside the follicle by granulosa cells diffuses back out into the blood vessels, and it gets carried all over. Now, this diagram, although it displays a human, really refers also to our dogs, cats, horses, and whatever. It's a kind of complicated diagram, but I'll walk you through it. The hypothalamus. Hypo means lower, below. The hypothalamus is tissue in the brain that's below the thalamus. Makes hormones. We've already talked about GnRH, gonadotropin releasing hormone. You can go back to the hypothalamic hormones if you need to. They're released, travel in a portal system, that's a blood supply, down to the anterior pituitary. And one hormone stimulates two different cells. These cells release FSH and LH. Okay, now remember, the LH goes to the theca cells. The theca cells make androgens, which we called, the most famous one is testosterone. But it diffuses across the basement membrane into granulosa cells, and in the presence of aromatase makes a lot of estrogens. Notice the O, estrogens, that's got to be British. That's okay. England, they spell it that way. Don't ask me why. I guess it's history, not an English major. Anyway, the other thing that are made by granulosa cells that we did depict earlier was inhibin. It's quite a name. Inhibin is a protein hormone that goes to the anterior pituitary, notice the minus, and says, quit making FSH. Some people don't believe this line, so I'm not going to talk about it. It doesn't really matter. Inhibin decreases the amount of FSH released. Now let's go back over to these estrogens. Androgens, like testosterone, get changed into estradiol 17-beta in the presence of aromatase in the granulosa cells. We just talked about that. They main libido, sexual behavior. They're also anabolic. They cause things to grow in our dogs, cats, and horses, as well as people. Mammary tissue is stimulated to grow by estradiol 17-beta. Also, other reproductive tissue grows because of the estradiol 17-beta. Very good diagram, and thank you so much.